Isomers are the compounds always that have the same molecular formula but different structural formula. What does it mean? For example, if you have here C4H10, you can have different structures or different bonding of this molecule, of the carbons in this molecule, but you should have the same molecular formula C4H10. For example, we have here, that's a butane. So if I draw one structure for it, I can just put 4 carbons back to back, just back to back. And that would be butane. You can see when you count the carbons and hydrogens is the same as this one. In another way, I can remove one of the carbons from the main chain and add it as a branch in the second carbon. Then I will have 2-methyl propane, and if you count the number of carbons and hydrogen, you see that is the same as this one. This is called constitutional isomers, are the compounds that have the same molecular formula but different structures or different bonding, different connection to them. Okay, so for example, in the exam they can give you different compounds and they ask you if they are constitutional isomers. What you're gonna do, you are going to find the number of carbons and hydrogens in each compound, and if all have the same molecular formula, they're gonna be a structural or the constitutional or structural isomers. Another name for constitutional isomers are structural isomers. So you can see when you add up these hydrogen and carbons here, you get C6H14, and also if you do for this compound, you get C6H14. How to find this? Always the first constitutional isomer will be just all of the carbons back to back, written back to back, like this one, the left one, the left structure. Just put all of the carbons back to back. This is gonna be always one constitutional isomers. Then in the second one, you remove the carbon. You look at the first one that you draw. That is this one on the left side. Then you will gonna remove one carbon from one side of it. Can be left or right side, and you put it in as a branch in the carbon other than the first carbon. Okay, so never put it in the first carbon when you remove it, because it's going to be the same, right? If I remove this and add it to the first carbon, I get the same compound. So there is no need to do that. We already have it, and it's going to be the same. We don't want to find the same constitutional isomer. We want to find the different constitutional isomer. So you're going to remove and you put it in the second carbon or third carbon as long as is not the first carbon. Okay, after you remove it, this is going to be the first carbon, right? Because this is going to be removed. So after you remove it, this is going to be the first carbon, this angle, right? You might just put your hand or your finger on the this line here. You see that after you remove it, this would be your first carbon. So always when you remove this, put it in the second carbon, okay, after you remove it. So then you can see that I remove this one and I put it in the second carbon. of the new compound. Then each time you're gonna name it after you draw it. So the one with the 5 carbon back to back, we just name it, we just learned it. This is pentane. Then this is gonna be the longest chain, the 4 carbon. We're gonna name from the left side is gonna because we reach the branch sooner to the carbon that has a branch sooner. So it's gonna be 2-methyl butane. And for this third one, you're gonna remove uh, another one from the one of the sides. This one that is in the right side, I'm gonna remove now this one, and I'm gonna add it in the carbon number 2 again, and I'm gonna name it again. This is gonna be the longest chain, just a 3 carbon. It can be this one too, doesn't matter. So it's gonna be uh, 2,2-dimethyl propane, formula of C6H14. So what's the first one we should do? The first compound isomer will be just a straight, all carbons back to back, okay? In the second one, you are going to remove the one of the branches from the either side and put it in the carbon 2 of the new compound. Then you can also move this branch as long as you get the different naming. You can just change the location of this branch. So you can see that also I can move it in the other another structure item, you can move it from the 2 to 3, the carbon number 3. Then uh, you are going to remove another branch and put it in the same carbon or carbon 2. That would be one compound, or you can just move it around to get the different compound. And make sure they are not repeated. Okay, they are not repeated isomers. That's very important. Always name them. And if they have a repeated names, you can just remove them because we don't want the isomers that have the same name. It means that we just repeated the same isomer.